For this next unit, we're going to be talking about vectors. So the first thing you want to write on your notes is kind of a definition of vectors. So vectors are directed line segments vectors have a direction, which in your mind will be something that's kind of similar to slope. Meaning it's what happens to like the x and the y coordinate, so horizontal and vertical components. And magnitude, which in this unit is going to be the math vocabulary term that really means the length. So when we talk about the magnitude of the vector, we're really talking about how long it is. So go ahead and draw a picture of a vector. So this end is point P, right here it's called the tip. The other end is the tail. Typically P is not drawn as a specific point, but you could say from P to Q, and P really means the point at the end, and then Q is the point at the other end. It has an arrow, and the arrow is telling you what direction it's going. So that's why you have an arrow. It doesn't mean that it goes forever, because these are line segments, but it just tells you the direction that the vector is going. So I'm going to go ahead and write that P is the initial point. And Q is the terminal point. And then the magnitude, and actually I forgot to write, hold on, let's go back up here. The way that you label this is you would say vector PQ, and you write it like that. Okay, so the magnitude of the vector you write this way. And I don't know what the two lines mean, to be honest. They're not absolute value, it's just how we write magnitude, but I'm not sure where that came from. If you want to know, I can maybe try to look it up for you. So the magnitude of vector PQ is the length from P to Q. All right, now there's a couple different ways to write vectors. One way is called the component form. So if we have a vector that goes from P to Q, you can graph these on coordinate planes. And so the point P would be x1, y1. And the point Q would be x2, y2. And so the vector in component form we would write as v1, v2. So the x coordinate, or the horizontal component, and then the vertical component. And the way that you find that is you would do x2 minus x1, y2 minus y1. And here it's important that you always start with the tail first. So the x2 and y2, that has to do with the tail, so those are the numbers that go first. And then the y, or the x1 and the y1 are the tip, and that's the part that goes second because it helps you figure out what your direction is. So be really careful to always do x2 minus x1. If you do x1 minus x2, you'll get similar numbers, but your direction will be incorrect. So the component form. And if you want to write on this, the component form describes the direction of the vector. And basically that makes sense because in slope you look at how the x's are changing and how the y's are changing, and so that's what you're doing in the component form. You're looking how the x's are changing and how the y's are changing. So I'm going to say this is the horizontal component. And the vertical component. And if you wanted to, you could label the x2 minus x1 as kind of like the run, and the y2 minus y1 is kind of like the rise. So we don't write it as a fraction like slope, but it kind of is the same thing. All right, and then we also know how to find the magnitude. And that is going to be written as the magnitude of the vector v is the square root of v1 plus v2. And since v1 and v2 come from this, what I really have down here is this is actually the distance formula, if you found the distance between 2 points on a coordinate plane. So we have direction and magnitude, and that is the way that vectors are defined. Okay, so here's an example to put in your notes. Let's say it says find the component form. And magnitude of vector RS given that R is -2, 5 and S is 2, -8. So first, to figure out what RS is with the direction, I'm going to say 2 minus -2, and I know that S comes first because it's the second letter in there, so it means that that's the tail. So that comes first. So 2 minus -2, and then -8 minus 5. And so RS, the vector RS, the direction, written in component form, would be it would be +4. And -8 minus 5 is -13. The magnitude of vector RS is the square root of 4 squared plus -13 squared. And so that is the square root of 185. All right, next we're going to look at equivalent vectors. And these have the same direction. So that means it's kind of like they have the same slope, so their horizontal and vertical change is the same, and magnitude. So they're the same slope basically, and then the same length. And location does not matter. Maybe think of like parallel lines if they didn't like continue forever and we were just looking at like a little segment of it. So equivalent vectors, same direction, same magnitude. So for example, show that vector RS equals vector OP given that R is 7, -3, S equals 4, -5, O equals 0, 0, and P equals -3, -2. So I just need to prove that these are both the same. So I'm going to go ahead and write RS in component form first. So RS. So it's going to be 4 minus 7, and then -5 minus -3. And so the direction of vector RS is going to be -3, -2. And then if I want to find the magnitude of RS, the magnitude would be the square root of -3 squared plus -2 squared. And so that is the square root of 13. Okay, so that's all the information for vector RS. Now if I'm going to look at vector OP for my component form, I'm going to have -3 minus 0. and then negative 2 minus 0. And so vector OP is negative 3, negative 2. And so if I look for the magnitude of OP, I can already see I'm going to do negative 3 squared plus negative 2 squared, and I just did that work right here, so I'm not going to do it again. It's just the square root of 13. So I can see that because these have the same direction and the same magnitude, that they are in fact equivalent vectors. Okay, and last in our notes, we're going to talk about adding vectors. And there are two different ways to do it. The first way to do it is algebraically. So if we're trying to figure out, we know that vector u is u1, that's a 1, sorry, u2, and we'll say vector v is v1, comma, v2, and I wanted to know what vector u plus v is if I wanted to add them together. Then I would say I would do the horizontal component added together, and then that's a u, and then the vertical component. So kind of the way you would maybe think it would make sense. So add the x's together, add the y's together, and then that would give you the sum of those. And then this answer right here, what you get when you add two vectors together, is called the resultant. So that is how you add them algebraically. We can also add them geometrically, meaning we can add them with the pictures. So you're going to draw U first, and then you're going to draw the tip of V to the tail of U. And once you draw that, U plus V goes from the tip of U to the tail, the tail of V. Okay, so having those directions out could just be helpful in the future if you have to draw these. So let's say this is vector U right here. Then it says the tip of V goes to the tail of U. So if this was V right here, and this kind of makes sense if you think about it, because if I'm thinking I'm adding my horizontal components together, then I would say, okay, so this part is horizontal, and then I'm adding that to this horizontal part also. And so that's going to put those together. And then if I'm looking at the vertical part, I guess U doesn't really have a vertical part, but then I would add it to this, which is the vertical part there. And so the resultant, when you draw the picture, is this, because that orange part would include the red horizontal components added together, and it would include the green component for vertical. So the important part to remember here is that you always do tip to tail. All right, so the tip to the tail, the tip goes with the tail, and then tip to tail, if that helps. Okay, another thing to write in your notes is that a vector, and maybe write this big because when we multiply it's going to be different. So a vector plus a vector equals a vector.